Hi everyone, I am Carla Maytapal with Carl Joseph Papuz and BJ Murphy. Today we're covering Chapter 7, Software Development, focusing on software quality and assurance. Software is everywhere, but what keeps it reliable and safe? We'll break down how development processes and quality checks ensure software works as it should for all of us who use it daily. Let's begin. What is high-quality software? Number 1. Easy to learn and use. The software is intuitive. Users can pick it up quickly without extensive training, and its interface is designed to match how people naturally work or interact with technology. 2. Fast and efficient. It performs tasks quickly, uses system resources like memory or processing power wisely, and doesn't cause unnecessary delays even when handling large amounts of data or complex operations. 3. Safe and reliable. It consistently works as intended, minimizes errors or crashes, and avoids causing harm to users, data, or connected systems, critical for applications in fields like healthcare or finance. 4. Secure. It protects sensitive information from unauthorized access, use, or modification with measures like encryption and access controls to defend against cyber threats. 5. High availability. Minimal downtime. The software is accessible when users need it, with very little or no unplanned outages, essential for services that people or businesses depend on around the clock. Why is software quality important? Used in critical industries. High-quality software is non-negotiable here. Sectors like air traffic control, healthcare, military and defense, and nuclear power rely on it to protect lives, maintain safety, and ensure public well-being. Even small failures could have catastrophic consequences. Business operations. Companies depend on stable software to run daily activities smoothly, from managing inventory and processing transactions to communicating with customers. Reliable systems boost productivity, keep operations on track, and support business growth. Risk mitigation. Quality software helps avoid costly issues like system crashes, data loss, and security breaches. These problems can damage reputations, lead to financial losses, or violate regulations. Strong quality measures act as a safeguard against such risks. Software defect and software quality. Software defect, a flaw or error within the software's code or design that has the potential to cause the system to malfunction, behave unexpectedly, or even fail entirely. These issues can arise from mistakes made during development, testing gaps, or changing user requirements. Software quality, a measure of how well the software aligns with the fulfills user needs, expectations, and specified requirements. It encompasses all the characteristics that make software reliable, usable, efficient, and secure, essentially. How well it does what it's supposed to do. Pressure in software development. Fast time to market. Teams face pressure to release software quickly, to capitalize on opportunities, meet market's demands, or stay ahead of trends. This can sometimes shorten development cycles and reduce time for thorough testing. Competition. With many players in most markets, Teams may rush to add new capabilities or match rivals, offerings which can divert focus from ensuring quality and stability. Need for profit. Budget constraints and business goals often push for cost-efficient development. This can limit resources allocated to quality assurance processes or lead to trade-offs between features and reliability. Sometimes, features are prioritized over testing. To meet user expectations or stay competitive, new features may be prioritized ahead or rigorous testing, increasing the risk of defects slipping into the final product.
So next slide, we have here cost of fixing errors, or what we call economic impact. This slide illustrates the rule of 10, or sometimes what we call 110-100 rule in software engineering. The core concept here is software development is cumulated process. An error in the requirement phase is just a sentence in a document. An error in the production is a broken product in the hands of thousands of users. So why it's 100 times more expensive? When a bug is found after release, you don't just fix the code. You have to re-diagnose the issue, fix the code, retesting the entire system, or what we call regression testing, redeploy the software, potentially deal with customer support cost, PR damage, or legal liabilities. Next, we have here software development methodology, or what we call frameworks. This slide explains why we use structure processes like Agile, Waterfall, or DevOps instead of winging it. Standard deviation: by defining activities, you ensure that every project follows the same quality gatekeeping. Accountability: it prevents the "I thought he was doing it" syndrome by assigning specific responsibilities. Risk mitigation: methodologies often include compliances and legal checkpoints to ensure the development doesn't violate data privacy law like GDPR or security protocol. Next, we have here quality assurance. This slide distinguishes quality assurance from quality control. So we have here proactive versus reactive. While many people think quality assurance is just testing the app for bugs, which is actually quality control, uh, quality assurance is about the process. So continuous monitoring, it focuses on preventing defects before they happen by improving the way the software is built. So the every stage mantra, this aligns with the shift left philosophy, moving testing and quality checks as early in the development timeline as possible to save money. So slide 9 next, we have here CMMI maturity level. So the capability maturing model integration, or CMMI, is a world standard report card for how professional a company's internal process are. We have here level 1, chaos. Success depends on heroic individual efforts. If the lead dev leaves, the project fails. So we have here level 2 and level 3, or what we call process. The company moves from project specific success to company wide standard. This is how we do things here. Level 4, data driven. The company doesn't just feel like they are doing well, they have the math to prove it. For example, our bug rate is 0.2% per 1,000 lines of code. In level 5, self-improving. The organization is so stable that it can focus entire on innovation and tweaking the system to be even faster and better. So, the narrative flows of these four slides is bugs are expensive late. So here we aim high CMMI maturity levels to ensure consistent excellence.
Next, we have safety critical systems. A safety critical system is a system where failure could result in serious injury, death, or major damage. Because of this system requires extremely careful development and testing. Examples include aircraft navigation system, hospital life support machines, nuclear power plant controls, and automotive safety systems like braking or airbags. In safety critical software, developers cannot assume that following a normal development process is enough. Extra safety measures must be implemented. For example, a project safety engineer is assigned to focus only on identifying and managing risks. A hazard log is maintained to record all potential dangers. Risk analysis is also performed to evaluate how likely a failure is and how severe its impacts would be. The development process includes detailed documentation, repeated testing, validation, and verification to ensure that the system performs safely under all possible conditions. The goal is not just functionality, but maximum safety and reliability. Now let's discuss ISO standards. ISO stands for the International Organization for Standardization. It develops international standards to ensure quality, safety, efficiency, and consistency in products and services worldwide. The ISO 9000 series focuses on quality management systems. These standards require organizations to establish clear procedures, proper documentation, regular monitoring, and continuous improvement. One of the recognized standards is ISO 9001-2008. This standard provides guidelines for building a strong quality management system that ensures customer satisfaction. The ISO 9001 emphasizes meeting customer requirements, improving internal processes, and consistently delivering high-quality products or services. Many companies aim to become ISO 9001 certified because certification increases credibility and trust. In fact, some government agencies and large corporations require ISO certification before awarding contracts. So basically, ISO helps organizations create structured systems that maintain consistent quality. On this slide, we have failure mode and effects analysis, or FMEA. FMEA is a preventive risk management technique used to identify potential failures before they happen. The process starts by identifying possible failure modes, which are ways in which a system or component could fail. Then the team analyzes the cause of those failures and the possible effects on users or the system. After identifying the risks, the team evaluates each one based on severity, likelihood of occurrence, and ability to detect the problem. The most serious risks are prioritized before corrective action. For example, if a software system might crash when handling a large data, the team will identify that as a failure mode, analyze its cause, evaluate its impact, and implement improvements to prevent it. FMEA helps reduce systems failures, improve reliability, enhance safety, and avoid costly errors after deployment. It is widely used in industries that require high quality and safety, and it supports ISO 9001 quality management systems.